You want staples? Yeah. You gonna take it with your teeth?
I'll have a better grip in my teeth than I have.
Okay. Hey guys, just put it up there. I won't lose it. Just put it on there. Yeah. Okay, there we go. Okay, this is a repeat of graphing, except today you're going to do your transformations, which means take your growth and do what? Slide it right, slide it left, slide it up, slide it down, stretch it, compress it, reflect. Okay, so I get to the ball. All right, ready? Today you will graph exponential functions by translating the parent function y equals b to the x. This is the parent. I'll repeat this in the next slide. I can also use my calculator to evaluate, cross this out, cross this out, cross this out. I can use my calculator to evaluate base E and find the interest compounded continuously. That's the last thing we're going to do. It's just a formula. It's really easy. Okay. Here comes your graphing right here. Okay. You have 3 to graph, and I think they get harder and harder as we go. The first one. Well, here's the deal. They are going to keep asking you this. What's the parent function? And here's the problem with exponential. When it's linear, the parent is this. What's that? It's just a line with a slope of 1. Okay, when it's quadratic, this is your parent. Do you remember what this is? What's x squared look like? 0, 0. Right 1 up 1. Right 2 up 4. Yep. So isn't this your parent? Do you guys remember this one? Absolute value?
It's a straight line.
That's a V. Starts where? 0, 0. And what does it do? Right 1 up 1. Right 2? Up 2. Yeah, it goes like this and it goes like this. That was you back September, October doing this, okay? Now you're into April. Well, now you're going to do exponential functions. What's the parent? Here's the parent. This you might want to write down. The parent will always be y equals, find your base, raise it to the x, and that's your parent. So when I say what's the parent, you'll tell me y equals whatever number to the x power. Okay, look here guys, you're going to graph this. But you're not going to graph that, you're going to graph the parent first, then do whatever transformations you have to do. So what is the parent function? It's always going to be y equals b to the x. Look up here. Where's your base? 5 is your base. It's just y equals what? 5 to the x. Oh, that's my base. That's my parent? Oh, let's graph it. This won't take long because you should be fairly good at this after yesterday. And I can make a long table, but really all I care about are 2 points. Guess what 2 points? 0 for x and 1 for x. Those two tell me the story. So what's 0 get you for an answer? 1. What does 1 get you for an answer? 5. And then after that, guys, you know it's just going to get bigger this way and smaller this way. Put a 2 in.
25.
Thank you. 25. Okay, then if you put little numbers in, like -1 and -2, I mean, you really don't have to because you should know these numbers are really, really what? Tiny, like just a hair above 0. So if you put -1 in, what would the answer be? 1 over 5 to the first. This one would be 1 over 5 to the second, which is 25. But again, see these numbers? These 2 points, that's what you concentrate on, those easy points. Where is 0, 1 and where is 1, 5? Well, here's 0, 1. and here's 1, 5. And you know this function is growth. So you should know it just grows really fast this way. And then on the other side is 0, what's it do? Negative 1, 1/5. Negative 2, 1/20. Doesn't stop. There's so little left. This number, if you graphed 1/5, you'd be about right here. If you graphed 1/25, you'd be right here. This is what you did yesterday on your assignment. You just always got it right on top of what? The x-axis. You guys, this is all you have to do to graph the parent. Just let it ride the x-axis to the left of 0. On the right side of 0, it's going to climb fast. And it really, really depends on the base. If the base is 5, you're growing really fast. What if I plugged in 2? What's the answer? 2. 25. Where's that point? Well, it's about right there. I'm not going to graph it. Unless I change my scale, I could, I suppose. Okay? Is this the answer? No. This is the parent. This is 5 to the x. What are we graphing? We're graphing. Yeah, this is what we're graphing. Y equals negative 0.5 times your parent. Right? Okay, so tell me what that 0.5 does.
Flips.
No, the number 0.5 does not flip it. Yeah, okay. Okay, yeah, it is. But I just wanted you to tell me transformations. Up, down, right, left, stretch, compress, reflect. Yeah, it's a multiplier. The multiplier is the stretch or the compression. That's below 1. If it's below 1, you should all be telling me what? Compress your graph by what? By 0.5, half, just basically half. Then you say, whoa, wait a second, this negative, yeah, you know what, the graph looks like this, guess what it's going to look like? This, when we're done. So it's a reflection over the x-axis, right? Reflect over x-axis. Okay, that's it. There's 2 things going on here. Okay, if I compress something by 0.5, what does that mean to you?
Divide by 2.
Okay, I can divide by 2, but what am I dividing by 2? Say it again.
Y.
The y value. So really every number you see here, 25, 5, 1, 1/5, 1/2, you're just going to multiply it by half. Or cut it in half. Okay, let's go here. The first point I'm going to pick on is this point. First thing I want to do is cut it in half. How high am I right now? 1. What's half of 1? 0.5. There it is. That's the new point. No, it isn't. You got to do what? Reflect it over x. So where would it go? Yeah, if I'm up 0.5, now I'm down 0.5. Okay, so here's the new point right there, guys. Okay. So I'm going to get rid of this. Okay, so the new point is just down a half. Okay, ready? Let's do this number right here, 5. I'm going to go compress the number by 0.5. So if I compress it by 0.5, this is up 5. What's half of 5? Oh, I'm right here. This is us. But wait a minute. I got to reflect it. Since I'm up 2.5, now where am I at? Down 2.5. Here I am. I'm down here. Hey, once I have 2 good points, I know what it looks like. If growth goes this way, up, 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 mine's going to go what? Down, down, down. Mine's going this way. Okay? Now, here's the hard part, because it's hard to visualize this. All these little tiny, tiny numbers, okay? If you cut these tiny numbers in half. So if you cut like 1/25 in half, is it still really small? Yeah, it's really just almost a little bigger than 0. Then you reflect it over the x-axis. Where are you going to sit? Right under the x-axis. Yeah, you're right. So basically, this is the graph now. The graph still rides the x-axis, but it rides it where? Underneath. Because you reflected it. It was on top, Well, now it's underneath. Do you get that? Okay, so this graph is the parent multiplied by what? Negative 0.5. There. There's what I just did. It would be nice if you label the parent and then label your real graph, because really, how do I know which one's your real graph? I want to know. Any questions on that one? That was just simply compression and then flip your graph. Okay? You're quiet. Are you okay? Okay, all right.
What about the domain range?
Oh, I didn't answer those. I'm sorry. Sorry. Let's go back. What's the domain and the range? So the domain are the x values that get answers. Hey, did 2 get an answer?
Yeah.
Yeah, eventually. Yeah, did 5? Did 4?
Yeah.
Eventually. Did negative 2 get an answer? Yeah. So what? What gets answers? Every x value gets an answer. All reals. Okay, what's the range? The range would be the y values that came out of this thing. Okay, well, let's look. This point got that answer. 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 That answer. What kind of answers are coming out?
Anything greater than 0.
Anything greater than 0?
Well,
Less than
Less.
0.
I think it's less than 0, isn't it? Like these are negative 5, negative 4, negative 3.
and you wanted that one or
No, of course I wanted
just that one.
the real function. This is the one we're supposed to graph. So it's got to be all y values are less than 0, right? Okay. What about this one? I know they didn't ask for it, but write it down anyways. What's the, I'll go right here. What's the asymptote? Now the asymptote is the line that your graph approaches, but never touches. It's the x-axis, but what's the equation to the x-axis? Y equals 0. Okay, so it's y equals 0. How come I told you to write that down? Because it's on the quiz. Okay. I'm going on. You ready? Next, graph this. Graph this, okay? What's the parent function, though? Look up there. Y equals, what's the base?
That's
Well, what's the base? 4, and just raise it to what? Just x. It's so simple. It's just 4 to the x, 5 to the x, 6 to the x. That's all it is. So if you want to graph your parent, just quick, throw in a couple points, and of course, by now you should know all I care about are those two. 0 gets what when you plug it in? 1 gets what? 4. And I know I can do another one with you. 2 gets what? 16. What does negative 1 get? 1/4. I'll be, again, honest with you. I care about those two. So if I graph them, 0, 1, 1, 4. I know it's growth. I know it goes up. I know it rides the x-axis. I'm done. That's the answer for the parent. But that's not what I want. I want this. 4, raise it to the what? X plus 2. All year long I've been asking you guys, when they wrap the x up in parentheses and they put a plus 2 inside, where are you going?
Left.
Is that left 2?
Left.
Yeah, it is. It's right or left, and it's the opposite of what you think. So this is a left 2. So you should be thinking, oh, this is easy. It's just left 2. So where would you go? Take your good points and go left 2. Right here. Left 2. Right here. And you know it's growth, so it's got to go up. Okay. But what's going to happen on the left side of that? Is it, no, what's it, I'm saying, what's it going to ride on top of? Is it still the x-axis?
Yeah.
Okay, if you took this point and you went left 2, you'd be here. This point, left 2, you'd be here. So really, it eventually catches right up to that other graph and just rides out on top of it, right? Hey guys, will you look for a second? You see this? This is your parent. If you go right or left, here's the asymptote. If I go right 2, did the asymptote change? Left 2? It's still the same. So what's going to change the asymptote?
Up and down.
Up or down will change the asymptote. That's it. That's the only thing that will ever change the asymptote. Okay? By the way, I'm done. This is it. This is, what is this? 4 to the x plus 2 power. There. Good? You guys are quiet, so I hope you get this. Okay, next one. Somebody say it. What's the parent in the next one?
2.
Y to the, y equals what?
2 to the x.
2 to the x. Don't say 2x, because if you say 2x, that's linear. 2 to the x, that's exponential. Go ahead, graph this. Get ahead of me, please. I'm not going to go over all this. I'm just going to tell you, I put all those numbers in. I got 1, 0 gets 1, 1 gets 2, 2 gets 4. Negative 1 gets 1/2, negative 2 gets 1/4. What's the 2 points I really care about? What 2?
1, 0, 1.
Yeah, these are the 2 I care about. I mean, the rest of them, I just know the graph goes up and the graph rides the x-axis. So it's basically 0, 1, 1, 2, 2, 4 is actually on here. Okay, and then it just rides the x-axis this way. This is 2 to the what? X. Okay, that's not your answer. Here comes your answer. You want to take your parent, 2 to the x, minus 1, and then add 3. So now we got to talk. Tell me what we're going to do to the parent. This means what?
Go right 3. Right 1.
Right 1. Okay, so the first thing you should do is whatever your grouping symbol says. My grouping symbol says go right 1. Okay, now guys, if you actually plugged a number in for x and you work this out, you'd say, if I plug the number 5 in, 5 minus 1, 4, 2 to the 4th, 16. What would I do next? 16, would I add 3 or would I multiply by 3? Yeah, order of operations says multiply by 3. So this is what you should say next. When I multiply by 3, what is that?
Stretch.
That's a stretch. By what? By 3. Okay. What's this negative do? Upside down. It's a reflection. Over x-axis. Okay. Okay. Last but not least, this is one you haven't seen yet. What happens in the back of the function when there's a plus 3 or minus 3?
Up 3.
That's up. That's an up 3. So what are you going to do to your parent? 4 things. Now this is confusing. Somebody in 4th period said to me, do I have to do this? Can I just make a table? And I said, of course you can make a table. If you don't mind putting in about 6 or 7 x values, because you're probably not going to see the function right away. You'll get a piece of the function, you won't get the whole thing. So you're going to have to make a long table. And I said, do it, whatever. And here's us trying to transform, okay? First thing we're going to do is go what? Right 1. Pick a point you'd like to pick.
0,
0, 1. Okay, let's do it. Ready? We take 0, 1, we go right 1. I'm right there. I just went right 1. Next, check. Next, do what? Stretch by 3. I am really surprised at how many students don't know what that means. When you stretch by 3, you only stretch what value? The y value. How high are you right now?
1.
You're 1 up. Well, okay. Take 1 times 3. What do you get? 3. Now you're 3 up. Okay, go up 3. Now you're here. Now you're at that point. But wait a minute. Now we got to do what? Reflected over the x-axis. So if you're up 3, guess where you're going to go now? Up 3? Down 3. No. I was just doing the reflection. Don't say down 6. Taylor, do you get what I said? Because you said down 6, didn't you? Well, who said down 6?
Me, because going from 3 down.
Oh, I get you.
That's all I said.
You meant down 6 this. Okay, I get it. But if you're up 3 and you reflect it,
Yeah.
you're down 3. Okay. Next. Now from there you go where? Up 3. Well, if you're here, you go up 3. Oh, look where you ended up, guys. You ended up at what? 0, 1 went to what? 1, 0. Oh, you did all that work just to go to 1, 0. Okay? But that's it. Okay, now we got to do it again. One more time. Pick another good point. Probably the next point. 1, 2. Okay. Here we go. Go to the right 1. Okay, I did it. Now triple your height. If you're at 2, guys, tripling your height, you're at what? 6. You guys with me? If you're up 2, triple 2, you get what? You get 6. You're right here now. This is where you're at. That's after tripling your y value. Now reflect it. You're up 6. Now you're what? Now you're down 6 right here. Then you're going to do what? Up 3. Okay. 1, 2, 3. Oh, there you are right there. That's it. Okay. Then I'm going to erase a couple things so you don't look at all this stuff. Okay, so there it is. Now, here's the deal. I know this is growth, but when you flip growth, it points which way? It points down. So your graph is going to go down. Now, what happens this way? Well, I know this thing goes out this way, so I know this has to go this way, right? Okay, but where's it? Where's the asymptote?
3.
What?
3.
2.
How'd you know it's 3?
Because I took the n number, and if it was originally on the x-axis, I just moved it up 3.
The n number? What's the n number? You said the end number. Which number are you looking at?
The plus 3 and
Oh, right here?
Yeah.
Okay, so you know that means what?
up 3.
Up 3. Okay, so up 3 means this asymptote has to move where?
Up 3.
Up 3. The only question I have for you is this. Where is it riding? On top of 3 or below 3?
Below, because you reflected it.
Yes, it's below because you reflected. So guys, when you do this point, go like this. Just go like this, and then find 3, there it is, and just go like that and ride right underneath it. The deal is, your asymptote will only change if you raise your parent 3 or drop your parent 3. And then, why did it ride below 3? Because it was a reflection. It wasn't on top of 3. It was below 3. All I care about is, can you get this point? Can you get this point? And can you get this point? And then do you know the asymptote is below the number 3? You're below this line. Okay. What's the range? Domain. What x values get answers?
All of them.
You sure? Did 5 get an answer? Look down. Eventually, it's gonna keep moving left. Yeah, you're right. All real numbers, all real x values get answers. What's the range? That would be the y values. Well, you can see right now it's -7 came out, -5 came out, 3, 1, 2 came out, 2.5 came out. What came out?
Y is less than 3.
Everything less than 3. All y's have to be less than 3. Okay? Last but not least, the asymptote. What line did it come close to but never touched? This line. What?
Y equals 3.
Y equals 3. The asymptote is y equals 3. Try to remember the asymptote is just a line, and it's always going to be y equals because it's horizontal. You okay? Do you agree with my period 4 student now? My period 4 student just wants to make a table and call it good. And they could, you could put in 0, you could put in 1, you could put in 2. You can do all that work, but look at that. You're going to have to get it right. It's a lot of stuff to do. You got to put a number in, subtract 1, raise 2 to that power, take your answer times -3, then add 3 to get your y out. It's a lot of work. Either way you do it, it's kind of a lot of work. This is very visual. If you're good at visualizing the transformations, this isn't too hard. But some of us just aren't that good at it. So maybe making a table is your best bet. All right, guys, there's more stuff down here. This is a summary of what you and I just did. So watch closely. You don't have to do anything. The first thing you do when you graph is do what? Graph your parents, right? Then you look for the stretches, the compressions, the reflections, and the horizontal and vertical translations, up, down, right, left. So they are telling you what all this is. And I'm not going to go over that. Okay. Okay. All right. Next, you have a quick formula here. Read this problem. I'll read it to you, but just read it with me. It says the initial temperature of a cup of coffee is 203 degrees. Yeah, it's really hot. Don't touch it. An exponential model for the temperature, Y, of the coffee. So what does Y stand for? Temperature of the coffee. After what? X minutes. X is the number of minutes that go by. So what's the temperature after 10 minutes, after 20 minutes? Okay. Here's the formula. Y equals 134.5 times 0.956 to the X plus 68. Here's the question. How long does it take for the coffee to reach that temperature, 100 degrees? Where did it start again? How hot was the coffee in the beginning? 203. How long does it take for the coffee to cool off? Well, this is an exponential decay or growth problem.
Decay.
It's decay, guys. Okay, think of the graph. At 0 minutes, it's 203 degrees. How long does it take to get to 100? Plug in your minutes, see what you get. Now you can start right now and guess, and just stick numbers in and just keep trying it. Or, here's an easy way, I think. Just get that 0.956 all by itself. Get it to equal a number. I think that's easier because then you don't have to punch in so much. So can somebody tell me how to get this equation down to this? What's the first thing you do?
Subtract 68.
Yep. Subtract 68. Knock out the 68. Oh, I forgot. What should I have put in for y? Yeah, when's it going to be what? 100 degrees. So if you subtract 68 from both sides, you get 32 equals this. I just have one more step.
Divide by 100.
Yeah, divide by the multiplier. Okay, 134 what? 134.5. Now you get 0.956 to the x power equals what? What's that divided by that? What?
0.24.
Give me a little more, like give me 3 numbers. 0.2. 238. Okay. So your job is to tell me how many minutes it takes for the coffee to go from 203 down to 100. And you know it's exponential growth, right?
Decay.
So, decay. I meant decay. Sorry. So you got to kind of guess. What number is this right there? What's that number? Well, you just have to plug numbers in. It's guessing time, guys. Put in 5 minutes. Does 5 minutes give you that? Does 10? Does 20? Try something. And then once you get an answer, say something to the group. Let's speed up the group. Anybody trying anything?
It's less than 8.
It's less than 8.
It's less than 78.
You're saying it's less than 8 minutes? Ooh. I think it's more than 8 minutes.
I'm typing it in.
Well, what did 8 give you? Here's my question. What did 8 give?
0.69.
0.69? Wait, yeah, you're way too high. So what's going to make it come lower? Your answer is 0.69, and you're trying to get here.
Oh,
You know, you're not even close. You got to keep. I would try maybe. How about 20 minutes later? What's 20 minutes?
0.4.
0.4? 0.4, you're getting closer. Anybody just about have it?
30 is, so it's
30 is to what?
low, so, but he said it,
32.
32.2.
Oh, 32.2 minutes. Is that what you're getting?
That's what I
Okay, so you tried 32.2 minutes and got what for an answer?
got. 0.235.
0.235, which is super close to that. So would we be okay to say Aaron said this many minutes?
Yeah.
Yeah, I mean, you could probably get a little closer if you wanted, but that's good enough. In about 32 minutes, your coffee went from 200 down to what? 100. Okay. You will have a way to solve that problem in about 5 days. In 5 days, we can solve that problem really, really quick. For now, we can't. We just have to kind of grind it out. Okay, next slide or next part of your notes is right here. This part in your notes was meant for you to discover what this number is. What is the natural base heat? Okay, I'm not going to take up your time. I'm just going to try to guide you through this. But in 7th grade, you guys discovered this number right here. Yeah, what did we call that number? Yeah, we gave it a symbol. We called it pi, and it's so important in mathematics, they programmed it into your calculator. Well, guess what? There's another number in mathematics that's really important. It's called base E. It's just a symbol that stands for a number. What's the number? Well, here's what they say. If you took this expression and you started plugging numbers in for n, the first number they asked you to plug in is 10. And then you plug 10 in here. And you'd get an answer. And what would happen is we would get really, really close to a number, whatever that number is. By the time you get to this number right here, guys, no matter what you plug in for n, it won't change. It's the same number. So I'm going to ask you to plug that number in, 10 to the 4th. Do you know what 10 to the 4th is? It is 10,000. Plug 10,000 into this formula and tell me what you get. I'll write it down for you. Plug this in and raise it to the 10,000 power. We can do this, but this takes a while. By right now, the number will never change, no matter what I put in after 10,000.
Is it 2.71?
I need a little more than that. 2.718. Yes. Okay. It does go on forever, but we're going to cut it off there, guys. It will never change. It stays what? Constant. Okay? So now here's the deal. It says, do the values in the table appear to be approaching a fixed decimal? Yeah, they do. If so, what is the number? Rounded to the nearest 3 decimal places. We already wrote it down. Thanks to Isaac. He gave it to me. There it is. That's the number for base heat. Natural base heat. Now again, this number is so important in mathematics. We use it in the business world, the banking world. It's been programmed into your calculator. Can you find it? Where do you see it?
Is it 2 capital E's?
What?
Is it two capital E's?
No, it's this is what it's not. If you see this, that's not it.
E to the X.
It's e to the x. That's it. So your job is to type. What I'd like you to do is hit that button, hit E, and raise it to the first power, and just tell me what you get.
Same number,
Yeah, you get 2 point what?
7182881.
Okay. So this number is basic. We will have to continue tomorrow to finish that up.
Please excuse the interruption for one short note. Girls soccer practice today will be in the new gym from 4 to 6.
Hey, there will be a couple problems at the very end when you hear continuously compounded interest. You can't do it. Wait, what? 23 through 27, he says. We'll talk about that tomorrow.
I was not able to stay tuned. I wasn't able to stay tuned again, I'm sorry.
Okay. You get that staple with
No. Oh, there's just a piece of, there's two staples that are stuck in there, just give me a game.
All right, I'll get it.
I think I'll watch a pair of pliers.